We can finally start blowing up the pieces of the building we made earlier. Let's go to the point in time when the spaceship crashes into the building. Choose the first piece, open the Object menu, and choose Quick Explode from the list of options. Based on the faces we added before, the object is turned into a particle system. The particles follow the rules of physics, like gravity and what happens when they hit each other. Now we have to change the properties of the particles to make them look like an explosion. Open up the Particle Settings tab. We can see that the frame start and end of the particles creation are the same. This is because we don't have to make new particles all the time. We can also change the particles' lifetime, which is how long they last before they go away. So, I'm going to increase this value, say to 300. Now we have to make the explosion more exciting. On the Source tab, we can leave the properties as they are. Open the Speed tab. I want to speed up the object's normal velocity, which is how fast it moves along its normal vectors. By making this number bigger, the particles move all over the place. We can also speed up tangent motion. Another important property is how fast the object is moving along its axis. We want the pieces to move a little in the direction of the spaceship. And this is, of course, because of the movement added by the impact. The spaceship moves about in the middle of the X and Y axes, as shown by the axis at the top right of the viewport. So, I can add the same value to the X and Y fields. Now, the particles are moving along with the spaceship. We must also turn on the rotation parameter and dynamic property. This lets the particles change direction based on how they hit other particles. As a final step, we can make the angular velocity a little bit faster. This is what is needed for the physical properties. But we can also create more particles. When we explode the next object, we'll be able to see this more clearly. So, go to the next frame and choose the next object. Now, we have to do pretty much the same things we did before. Now you can do it yourself by moving one frame at a time, choosing the next piece, and repeating the explosion effect. The final step is to make sure the particles hit the ground and bounce back. Right now, they just pass through. To do this, we need to choose the ground and give it the collision property. Now, the particles are falling and bouncing on the ground. We have to make some adjustments about the collision effect, of course. Damping is a good way to reduce the force of a collision. With Kill Particles, we can get rid of the particles when they land. Stickiness refers to the tendency of the particles to stick to the ground. Now, all we have to do is change these settings until we get the result we want. With damping equal to 1, all of the energy of the collision is absorbed by the ground. When you have a particle system like this, you often have particles that keep moving. In this case, increasing the stickiness value can be helpful. This is the final result. We can see a problem in the way the particles interact with the building's floors. They always move and turn. As was already said, this is a common issue when dealing with the collisions of particle systems. I also gave the building the collision property, since the particles have to hit it. But I didn't change the stickiness of the floor in this case. They would have been stuck to the floor. So we finished this part, which was related to the explosion with a particle system. We have to destroy the spaceship now. In this case, I won't explode it as the building. I just want to separate all the parts that make it up. I want each part to act like a rigid body, falling and colliding with other objects. So, we have to deal with another simulation, which is of rigid bodies. So, we can give each part of the spaceship a mass and some physical properties. But before I do that, I want to join some pieces together, so that we have fewer pieces to deal with. So, for example, I'm going to join the parts of each wing. Now we can choose all the objects, and choose Add Active from the Rigid Body menu. Blender adds the rigid body property to all of the pieces in this way. But before we do that, let's do it manually for a single piece. The first choice is whether or not to make the object active. Active means that the object is subject to all physical forces, like gravity and so on. In fact, the object does fall down. On the other hand, passive means that the object acts as an obstacle for the other objects in the simulation, but it isn't affected by forces like gravity. So, we need all the objects to be active. Choose all of them, and mark them as active. Now, the objects start to fall. The mass is another important property. By default, the weight of each piece is the same. But keep in mind that the simulation heavily depends on the mass value. So it's important to put it at a value that makes sense. We can make Blender figure it out for us automatically. Select all the objects, then go to the Rigid Body menu and choose Calculate Mass. We also have to choose the materials. In this case, iron. The mass of each piece is set automatically, based on the material and the size of the object. So, when we start the simulation, the objects fall to the ground and no longer follow the empty object. But we want the pieces to follow the empty object until it hits the building, at which point they should act like rigid bodies. This is possible because of the animated property. It lets a rigid body be animated by hand, like in this case, while still being able to collide with other objects. I basically want to animate the animated property. It has to be active until the spaceship hits the building. Then we just turn it off. To set the same property on multiple objects at once, we can select them all, and press the Alt key, before setting the property we want. On the other hand, we have to turn off the animated property from now on. Choose one of the objects, in this case the first one, move the mouse over the animated property, and press the I key. This makes a new keyframe. Go to the next frame, turn off the property, Animated, and press I again. For the other pieces, we have to do the same thing. We can do this by copying this animation to the other objects. Click on the first object, which is where we created the animation, and shift-click on the last object. In this way, the first object becomes the active one. Then, from the Link, Transfer Data menu, choose Link Animation Data. In this way, we copied the animation from the active object. If we start the animation, we get what we're expecting. The pieces move until they hit the building, at which point they stop moving and act like rigid bodies. They separate from each other and fall down because of the force of gravity. The final step is to give the ground the rigid body property, so it can interact with the spaceship. In this case, it has to be set to passive, of course. In the full course, we will see how to carry out all the other simulations, such as the rigid body simulation for the spacecraft's impact with the ground. The simulation of debris from the impact, and the smoke rising from the ground. The animation of the pilot. The explosion of the glass sphere. The simulation of liquids and water splashes. And much more, such as materials, optimization of simulations, and final rendering.